Welcome back to All This Math. This is Professor Parker. Make sure you subscribe to the All This Math YouTube channel. Make sure you drop a comment down below. Make sure you like this particular video, and make sure you excuse me. Make sure you share this video with some other people. All right, let's get started. Let's first take a look at what we're going to do today. Today we're going to deal with functions, more specifically composite functions. Composite functions. This is something you might see in an Algebra 1 course, maybe even an Algebra 2 course, right? Well, I mean, you're gonna see it. You can see it in calculus. You're gonna see it in pre-calculus, right? But I should say it'll be introduced in an Algebra 1 course, probably. You know what I mean? At least introduced this way. Composite functions. What is a composite function? Composite function is basically like when you take a function and you put it inside of another function. All right. A function is like a machine, right? It's got input and output, right? You put something in it, something comes out, right? Just like you input hours of study. What's the output? Better understanding, high grades, most likely, input and output. But, you can also take a function and put it inside of another function. So let's take a look at what we have here. This says let f of x, we read that f of x, not f times x, not f times x. When we're dealing with functions, I know it looks like f times x, but we read it differently because it's a function. It's called function notation. So we got let f of x equal x squared minus 4. So this function, so the f stands for the word function. Like f is like the name of the function, right? The x is the variable that would be your input, right? Input or independent variable, right? The output is going to be the f of x. So f, the value of f is going to depend on whatever x is, right? Just like how certain people, right? Certain people can affect you in a certain way, right? Whoever's present, that's why sometimes before we go places, you might ask the question, who all going to be there? Because you might feel a certain type of way if certain people are going to be present, right? Your mood might be dependent on who's there, right? So your mood, right, is F. The people present might be X, right? They affect you, right? You got dependent variable, independent variable. Your feeling and your mood, like, you know what I'm saying? Like, just like some people are affected by the weather. When it's sunny outside, they happy. When it's raining, they sad. They don't see the value in it raining. They don't think about, well, if it never rained, it wouldn't be, we wouldn't appreciate the sun as much. We wouldn't have food. Plants wouldn't grow, right? But anyway, dependent and independent. So we got this function right here, x squared minus 4. The input is going to be x. So that means we can replace x with different numbers, and it's going to give us a different output depending on what the number is, right? The output is going to be f. F is also the name of this particular function. The function could be called g, could be called h, could be called r, could be called I, could be called a, whatever, right? And we got another function, g of x. See, like I said, this function is called f. This function is called g, right? Two different functions. It could be brothers, it could be sisters, whatever. They could be cousins. You know what I mean? Similar situation. G of x is equal to 3 minus x, right? So 3 minus x is the expression, right? That's the actual function. The value of x, let's say you put a 5 in there, that's going to give you a certain g. But if I put a 2 million in there, that's going to give me a different g. If I put -8 in there, that's going to give me a different g, right? So the value of x is independent. That's going to determine what g is going to be, right? And just like in life, right? Certain situations, what you do will affect your life. What you do today is going to affect what you do in 10 years from now, right? If you do a certain thing today, your life is going to look a certain way 10 years from now. If you do a different thing today, your life is going to look different 10 years from now, right? Just like the function. Whatever number I put in place of x is going to affect the outcome of this function, right? G and x, right? So x is the input, g is going to be your output after you do the math, all right? Now, but with composite functions, that's when we take one function and put it inside of another function. So part A says find f of g of 5. That's what we say. F of g of 5, right? G of 5 is inside the parentheses. F of g of 5. Now, different people do these different ways. The way I tend to do it is I tend to work inside out. Inside out. Meaning I look at what's most inside. I see g of 5 is on the inside. So since g of 5 is on the inside, I'm going to evaluate g of 5, right? I'm going to do that first. And then I'm going to take that number, whatever that's equivalent to, and then that's going to be f of that number. And then I'm going to evaluate that. I'm going to put it in f. So first, what's on the inside? G of 5. So G of 5 is like this. So now, first things first, you got to understand this. G of 5 don't got nothing to do with this up here because this is F. This is F. G of 5 got something to do with this. This is G, right? G deals with G. So now we got G of X equals 3 minus X. So in the place of X, I got a 5. In the place of X, I got a 5. So that means in this expression, I'm going to replace the X with a 5. So I'm going to do G of 5 is equal to 3 minus 5. Now, what does 3 minus 5 equal? We got to know how to do arithmetic with positive and negative numbers. 3 minus 5 is not positive 2. 3 minus 5 is negative 2. If you're on a number line, right? Always picture the number line. I highly recommend it. If you're on a number line at positive 3, and when you subtract, that means you move to the left on the number line. How far do you move? 5 spaces. Where do you stop at? You stop at negative 2. If you start at 3, move to the left 5 spaces, you're going to end up at negative 2. So that means that G of 5 is equivalent to negative 2. G of 5 is equivalent to negative 2. So what does that mean? That means that in this composite function, I can replace G of 5 with this number negative 2. I can replace G of 5 with the number negative 2. And who told me I could do that? The rules of mathematics, the rules of algebra, because G of 5 is equivalent to negative 2. They are equivalent. They are the same thing. They mean the same thing. So then I can go and say, all right, well, if G of 5 is the same thing as negative 2, that means I could say, instead of saying F of G of 5, why can't I just say F of negative 2? And the answer is you can. You can do that. And you should. So now I got F of negative 2. Because what? It was F of G of 5. But G of 5 and negative 2 are the same thing. And how I know that? Because I did the math. Because that was G of X. I replaced the X with the 5. I did 3 minus 5. Replace the X here, replace the X here, replace the X here, replace the X here. Right? Now, F of negative 2. Now I'm dealing with this function. Now I'm not dealing with G no more because the letter F is here. Dealing with the F. So now I replace all X's with the number negative 2. Now, be careful. When you see a situation like this, you got a variable with an exponent. Make sure you use parentheses around the number that you replace. Make sure you use parentheses. So we're gonna put negative 2 right here. The exponent 2. Now again, make sure you do that. This is key. This is a very common error that students make. They'll just replace the X and not put parentheses. If you don't put parentheses, you're creating a different expression, and it's going to lead to you getting a wrong answer in most cases. All right. And then you're going to put minus 4. And then we just use order of operations, right? So we're going to have negative 2 to the second power. Negative 2 to the second power means negative 2 times negative 2, which is positive 4. Negative 2 times negative 2 equals positive 4, not negative 4. It's not negative 4. Don't play around like that, right? Negative 2 times negative 2 is positive 4. So then you got positive 4 minus 4, which is 0. So that means that the final answer to this is 0. Is 0. That's a composite function, right? You have a function inside of another function. The function G is inside of F. The function G is inside of F, right? It's almost like if you had like a parasite in your stomach, right? A parasite living inside of you. Like you are a living being, right? But then inside your body, unfortunately, you might be eating some pork or something, right? You know what I'm saying? Something unhealthy, right? You might have a parasite inside of you because of that, right? That's like a composite function, right? I know that example's a little graphic, but you know, hopefully it works. All right, so now let's go to choice B. Let's go to example B. Now we're doing it the other way. Look what happened. It says find G of F of 5. G of F of 5. So G of F of 5. So what I would do in this case is I would find F of 5 first because I like to work inside out, inside out, inside out. I would find F of 5 first. So I go to F, and it's going to look like this. It's going to be F of 5, which equals 5 squared minus 4. So we got 5 squared minus 4. So 5 squared. Now 5 squared is not 10. It is not 10. 5 squared is not 10. 5 squared is 25. 5 squared is equal to 5 times 5. 5 squared is 25. So we have 25 minus 4, which is 21. So F of 5 is equal to 21. So F of 5 and 21 are equivalent. F of 5 and 21 mean the same thing. They have the same value. f of 5 is 21. So this function has a value of 21 when x is 5. Now, this is why, like I said already, the x is the independent variable. But if x was another number, then f would be another number. If x was even a different number from that, then f would be a different number, a different value, right? If you put -8, it's not going to be 21. It's going to be something else, right? Independent, dependent. It's all about cause and effect. What math shows you, what algebra shows you is cause and effect. We can't just focus on the effect, right? Don't just focus on 21. How did 21 get there? Because it's a 5 right there. Focus on that 5. So when we look at human behavior, look at people outside in the world, in the street, acting crazy, right? Don't just look at the end behavior. How did they get there? What caused that? What caused that? A lot of times we don't like to do that, right? Right? We don't like to talk about, well, how did they get there? What caused the behavior? Who's benefiting from that bad behavior? We don't like to talk about all that. We just like to focus on the end result, the outcome, right? Because it's popular and it's cool for some people to just, talk about the negativity of the end behavior. All right, but how did they get there though? That 5 right there. What if the 5 was different? And who benefits from there being a 5 right there? I want y'all to start thinking about this. The algebra be letting you know, right, about social dynamics and social situations, right? Social relationships between them and among human beings. This is sociology. This is psychology, right? The algebra is in there. The algebra shows you, right? But anyway, f of 5 and 21 are the same thing. So now we got, instead of writing g of f of 5, I could write g of 21 and figure that out. G of 21. Again, what gives me the right to do that? Because this says g of f of 5, but I just did the mathematics and I figured out that f of 5 is equal to 21. How do I know that? Because f of x is equal to x squared minus 4. So if I replace the x with a 5 right here and right here, now I'm doing 5 squared minus 4. 5 squared minus 4. Use the order of operations. 5 squared is not 10. 5 squared means 5 times 5. 5 times 5 is 25. What's 25 take away 4? It's 21. Now I got g of 21. G of 21, now I'm going to the g function, is going to be equal to 3 minus 21. So we got 3 minus 21. Make sure we know how to add and subtract positive and negative numbers. If we start at 3 on the number line, when we subtract, we move to the left. We move to the left. How many spaces? This says move 21 spaces. 3 take away 21 is going to be negative 18. So this is our final answer for our composite function. And that's how we deal with composite functions. And sometimes it'll be more than 2 functions. This is G and F. Sometimes it could be another function inside of that. Sometimes it could be 3, 4, or 5 functions, right? But you do it the same way, right? You follow a systematic method, all right? What I like to do is work inside out. What some people do is this. Some people will do this. So let's take this one right here, right? Instead of working inside out, they will rewrite this in the form of both functions at the same time. So I'll take the G. The G is on the outside. The G is on the outside. So that means they'll write this first. They'll do 3 minus, see, 3 minus, and then whatever x is, that's where you put the f of x. So they'll do this. X squared minus 4. So look at that. G of f is going to be the G function on the outside. And then inside the G function where the x is, you replace it with this whole expression, right? So then you end up with 3 minus x squared plus 4. Why is it plus 4? Because that's minus a negative, minus a negative, minus a negative. That's a double negative, becomes plus 4. This is minus a positive, which becomes minus. So then we got 3 plus 4, which is going to be 7. So you got 7 minus x squared, right? So that's that's another way to show the actual composite function, right? With both functions combined, right? And then you replace the x with a 5, which is going to be 7 minus 5 squared, which is going to equal 7 minus 25. Notice we're not doing negative 5 squared, we're doing positive 5 squared. Positive 5 squared, because that's a positive 5 right there, right? Then we got 7 minus 25, which is going to be negative 18. So you notice how that's another way to do it. Some people prefer to do it that way. And that's cool. That's cool too. You could do it that way too. You know? So yeah, but if anything confused you, please drop your question in the comments. Drop your question in the comments and I may make a video specifically pertaining to your question. All right. Make sure you subscribe to the channel if you didn't already. Make sure you share this video. Make sure you like the video. And that's about it. I'll see y'all on the next one. Peace.